Number one. Shh, guys, it's recording. This could be why I don't get anything done. The figure shows two perpendicular lines, S and R, intersecting at point P in the interior of a trapezoid. Line R is parallel to the bases and bisects both of the trapezoids. So that means that's parallel. If it's parallel to both of those bases, then obviously that top and bottom line is parallel. Yes?
When it says maps itself onto it, that means it like goes like
completely like onto itself, no overlap. Okay? Yes.
Has anyone taken the EOC yet? Like any other school?
No, not that I'm aware of. Can we answer those questions when I'm not recording?
Yeah.
It says it bisects both of the legs. That means that part is going to be equal to that part, and that's congruent to that. Okay? But I think you can see if I reflect it on line R, then this point that's wider is going to be sticking up like that. Correct? So that's not going to map it onto themselves. Basically, what you're saying is R would not be a line of symmetry for this figure, correct? If you reflect anything over a line of symmetry, it's going to map onto itself. And the reason I mention that is because if I reflect it on line S is a line of symmetry. That's why the correct answer is line S. This has no rotational symmetry until you get to 360 degrees. It has one line of symmetry, correct? Line S. And remember, we learned earlier in the year when we did this unit that if you take 360 and divide by how many lines of symmetry, in this case there's just one, you'll get its rotational symmetry. Okay, it's not how many sides, it's how many lines of symmetry. Okay? So that's why 1 is B. Number 2, in the diagram below, C is the circumcenter of X, Y, Z. Okay? Classify each statement below. If this is the circumcenter and it sits on the hypotenuse, this must be a right angle. And if this is a right angle, we said a right angle that is inscribed in a circle, the hypotenuse will be the diameter. That's how I know that C is also the center of the circle. You may not have realized all of that. You might have just assumed that. That's okay, but mathematically there's a reason there, which means that C to X is congruent to C to Y because they're both radii. So A is correct. By the way, C to Z would also be congruent to C to X and C to Y, correct? Because it's also a radii. C to Z is not congruent to XY, correct? CZ we can see is the radius, XY is a diameter. C, X, Z is isosceles. Well, I know that C to X and C to Z are congruent, so it is isosceles. Even if all three sides are congruent and it's equilateral, it's also isosceles. C, Y, Z is not, yes?
How would you prove that it's like not or is equilateral?
How would you, okay, so in this case, this to here, the radius is basically going to be like longer than that. Does that make sense? Okay? So that's not congruent to that. So CYZ is not an equilateral triangle. XY is the diameter of circle C. And we can prove that because this angle here has to be a right angle. And then when a right angle is inscribed in a circle, the hypotenuse is the diameter. Okay? If you put CYZ as equilateral, I don't know whether you get partial credit for the ones you get right or you don't. The people who write the EOC, the state doesn't really tell us, and there's differing opinions. Based upon student scores last year, it looked to me like some of my kids, based upon the scores that they got, like they had to give some kind of partial credit. Because whatever the highest score was, I think the highest score you can get on a scaled score is a 575. And I had one student get a 571, and I had one student get a 572. So, like, that seemed to me like probably there's some partial credit in there somewhere, because it wasn't like even increments. Yes?
So can you, if you have a notebook, can you put like all the answers and get partial credit?
I don't know. That's a good answer. If you have no clue, I would still try and pick like the few that you think you know. Because I don't know what, at that point they might say like, hey, it's obvious the person was just guessing. We're not going to give them any credit.
Does that person and the machine grade it?
It's actually a machine. It's actually all computer generated, and it's like there's algorithms, and it's comparing your answers to other people's. They always catch somebody at this school for cheating, so don't cheat. Because they find that your answers are just way too similar to the person sitting next to you. And it's always two people sitting next to each other. They make you retake it. And it's always just mind-boggling to me because remember, guys, you don't get the same questions in the same. Circle F is divided into sectors, okay? In circle F, they're telling me that EB is the diameter, and they told me that F is the center. So I know that these are all radii, correct? Okay. So what I did when I did this problem was I first figured out that sector AED, because that's ultimately I want to find that arc length. So AED is created by an angle that's 165 degrees. I did 360 minus 120 minus 45 minus 30. And I got 165. They don't tell you to have your answer in radians. How do you know by looking at this that you want to have your answer in radians? It's in, not degrees, it's in pies. The answer choices are all in pi symbols. That's the way you know you want it in radians. So what I did first was I converted 165 degrees to radians by taking 165, making it a fraction over 1, and multiplying it by pi over 180. Yes?
I did 165 over 360, and I still got the.
Oh, you did 165 over 360, but at some point then you converted it to radians, right?
I think, yeah.
Okay, at some point you have to convert it to radians. I just prefer to convert to radians at the beginning. That's just me, okay? So when I multiply this across, I get 165 pi equals 180. I simplified that to 33 pi over 36. And then I simplified that to 11 pi over 12. Because I couldn't get from 165 over 180 to 11/12 all that quickly. Okay? I'm going to erase what I have here, and then I'm going to set this up. So I had 11 pi over 12 is the measure of the central angle, all over 2 pi. So Tyler, you said you did 165 over 360. You're doing it in degrees at this point. That's fine. Okay? Now I want to find the section that represents the arc length. And arc length means I'm using the circumference. Okay? So they told me that F to B is 3 units. Remember, circumference is 2 pi r. So the radius is 3 times 2 is 6 pi. Okay? This is where it's going to start to get a little complicated for you guys. I'm going to cross multiply. I'm going to go over here. 2 pi times x is 2 pi x. 11 pi over 12 times 6 pi. So the numerators of my fractions are 11 pi and 6 pi. That gives me 66 pi squared. Divided by 12. Okay? If I wanted to, I could simplify the 66 twelfths. Okay? Do you want to simplify it now or later?
No.
Now? Okay. So, what are we dividing by? I'm going to start with 6. I'm going to start with 6. I don't think 66 is divided by 12. So I'm going to do 6. 66 divided by 6 is 11. And 12 divided by 6 is, okay? Now what do I do?
Use squares.
Subtract the 2.
No, you don't subtract the 2. You don't divide, you multiply. Basically, if it helps you guys, if you're having trouble seeing it, you actually have 2 pi x equals 11 pi squared over 2. You're getting rid of that dividing by 2 by multiplying both sides by 2. 4 pi x equals 11 pi squared. Now, you can do 2 different things here. You can divide both sides by 4 and then both sides by pi. Or you can divide both sides by 4 pi at the same time. I'm going to do that. Even if you got confused with these pi's here, hopefully at this point you recognize 11 over 4. Ooh, 11 over 4. Right? But 1 pi on the bottom and 2 pi's on the top means this pi cancels out and this pi becomes 1 pi. Okay, the problem with these is not setting them up. The problem with these is the multiplying with the pi's and the fractions. Does that help with number 3? Okay. Number 4. Okay, so for number 4, here's what you got to do. First thing you got to do, when you don't have a clue what to do, does anybody know what you do when you don't have a clue? Who said it? What did you say, Rama?
Draw it out.
Draw it out. Draw a diagram. Ooh, we can call it Dad. Hopefully y'all get along with your fathers. Just call, sorry. Okay. Okay, call Dad. Okay? Call the person you would like to be your dad. Okay? Okay, Dad, draw a diagram. Camellia is, oh, I shouldn't have said the name. She's going to call Barack. What would Barack do? I think that's probably good. You know what? Barack might be able to help me more than my father. You know, so, okay. So, AC is a diameter. B is the center. They're saying D is anywhere on the circle as long as it's not A or C. So I'm going to just put D there. Okay? Now, B to D to A is 20. Okay? What? Yes?
I thought it was saying angle because when it says an angle, you can't have
Yeah. B, D, A. That's the angle. That's the angle right here.
Yeah, but usually, like when you say an angle, it would be like ABD or DBA.
What is the center of that angle, BDA? D. Okay, so that's what we're saying. You could have called it, they could have called it ADB or they could have called it BDA. They want you to understand that that angle there is 20 degrees. Okay? Now, this is the part that you might now get stuck and say, I don't know what to do next. So maybe by going through these, it starts to trigger things. I have a hypotenuse. I have a diameter. A diameter can also be a hypotenuse in a right triangle, correct? Correct? So I can draw a line here from D to C. And BDC has to be how many degrees? not 180, BDC. So just this angle right here.
160.
Just this angle.
180.
This angle is 90. So this part is, somebody's saying it over here, 70. Okay? This is 70. So this is getting messy to read here, but B to D is a radius, right? B to C is a radius, correct? B to A is a radius, correct? I eventually want CBD. I want this angle here, right? So honestly, I'm not even dealing with this triangle anymore. This triangle with the 20-degree angle just helped me get, and I'm going to try and draw this a little neater over here. Triangle DCB. And I know that this is a 70-degree angle. I also know that B to D is congruent to B to C. If B to D is a 70-degree angle, B to C is a what? Sorry, if angle D is a 70-degree angle, angle C is what? 70. How'd you know that? It's an isosceles triangle. It's base angles theorem. These base angles are congruent because they're opposite congruent sides. Okay? So if this is 70 and this is 70, that adds up to 140. So angle B is how many degrees? 40. These two add up to 140, so B is 40. The 20 only helps you to get this angle here. And you're right, you could look at this and say, I don't have a clue. But maybe once you start drawing out a diagram, even though you don't know where to put D, this would have worked no matter where I put D, right? Because no matter where I put D, I would have created a triangle that was inscribed in a circle that had its hypotenuse as its diameter, so any of these would have been right angles. You understand it? Say it loud for the video. Yay!
I forgot we were recording.
Yes, we're recording. So sometimes I have to prove that, kids actually understood. And is it me or is it really hot in here or am I just sweating?
Yeah, it's kind of hard.
Okay.
I'm fine.
Okay. Yes. What? Okay, so number 5. Did anybody have a problem with number 5?
No.
Okay? Basically, when you rotate anything 360 degrees, so just so you can see, even when you rotate a square, because this edge side is spinning here, it makes a circle at the end. Okay? Number 6, we have to be able to complete the square. Okay. The radius of the circle represented by the equation x squared plus y squared minus 4x plus 2y equals b is 7 units. Okay? The radius is 7 units. That means when I finally get it into standard form of an equation, remember our formula is x has the x's and y's on this side, and this is the radius squared. So this has to equal 49. Okay? So we know that that's equal 40. Now let's look at trying to get this into the equation of a circle. So I'm going to have to complete the square. To make this easier, I'm going to take my x squared minus my 4x. I'm going to put those together. And then I'm going to put my y squared term plus my 2y together. How do I complete the square? Who remembers?
You multiply like x squared times y squared.
No. No, you don't FOIL. What do you do? You take half of another number. What another number do you take half of? The b term. You take half of the b term and you what? Square it. So half of the b term is negative 2. Squared is, so you're adding 4 here. The b is the number, that. Okay? And then in this y part, what's half of the b term? 1 squared is. Now here's the thing. Okay? You have b over here. Remember, your original equation had b. But you've added 5 to the left side of the equation, correct?
Yeah.
So you need to add 5 to the right side of the equation.
Where did you get 49?
Okay, look at the original problem.
Uh,
49, I'm just holding out here at the end. This has to be equal to 49 because the radius is 7. And the format, remember, is x minus h quantity squared plus y minus k quantity squared equals the radius squared. That's our formula for standard equation of a circle.
what's the K and H?
The k and the h, you should remember that. That's, okay, we'll get to that. The k and the h is your x coordinate of your center, and the k is the y coordinate of your center. Okay? We completed the square. In order to make this a perfect square trinomial, we added 4 here. To make this y part a perfect square trinomial, we added 1. 4 plus 1 is, so we have to add 5 to the right side of the equation. Okay? So, now I'm going to factor this. This is x minus 2 quantity squared. Okay? This is y plus 1 quantity squared. Yeah. You took half of the b term. The b term is your letter in front of the single variable. So what's half of negative 4? And what's negative 2 squared? Yeah, that's where I got the 4 from. What's half of 2? And 1 squared is, so I added 4 here, I added 1 here. Okay? I can do whatever I want to one side of the equation as long as I do it to the other. Okay? So, the standard form of this equation is x minus 2 quantity squared, y plus 1 quantity squared. This means if this were a circle, the center of it would be at 2, negative 1. But b plus 5 has to equal what? 49. So b has to equal what? 44. Because 44 plus 5 equals 49. Okay? If it doesn't, then this equation doesn't work. You don't realize, which I understand, how much work goes into actually coming up with math problems for you in your homework, in your quizzes, in your tests, where the number actually works. Okay, that's why I typically try and find problems. I don't just make them up off the top of my head, because if I do, they end up with weird decimals. Okay, is that a little bit better? Did that help you out over here, Oregon Trail? Okay.
I just wondered about like the different questions.
Wasn't that the one you had a question about, or no?
When you do the problem and there's a different one, when you do the one equation there, and like I want to find another way about negative 1, so I didn't know, and say that one was positive.
Okay. Can you find the other one? We may not get to it today, but at least I know. We're halfway through our intended recording for today. I think when I put these up as movies, I'll actually have to put up like 1 through 12, 13 through whatever. Otherwise, the movie's going to be like 7 hours long. What? I could, but then you would miss all this fun banter. Okay. Okay, 7. Okay, so I love 7, but you got to try writing some stuff. Okay? So, since this side is opposite angle C, I'm going to call it lowercase c. Since this side is opposite angle B, I'm going to call it lowercase b. And since this is opposite angle A, I'm going to call it angle A. So they're saying let sine of B equal R. How would you write out the ratio for sine of B? It would be opposite over hypotenuse, right? So sine of B would be opposite, so lowercase b, over A, correct? And they want that to be R. So right now I'm just drawing out different symbols. And for the cosine of B, yes?
Why did you label it differently? Like you put the lowercase c and a and b. Like, why did you do that?
Because that way I can remember that my capital letters are my angles and my lowercase are my sides.
Oh.
I could have used X, Y, Z. I just felt like it just made a little more sense to me. Okay? So how would I write out cosine of B?
Adjacent or
So that would be C over A, which equals S. It's SOHCAHTOA. So now, how would I write out sine of C? Sine of C is opposite. No, opposite over hypotenuse. So C over A. So sine of C is C over A, which also could be written as letter S, because C of A worked for cosine. Okay? What they're really testing here, and you may not remember it, so you can write that out, that the sine of B is going to be equal to the cosine of C. And the sine of C is going to, okay, cosine of B, sine of C, sine of B is going to be equal to the cosine. But if you don't remember that, which you can start writing some stuff out. So cosine of C would be B over A, which is R. So the the sine of C we can write as S, minus the cosine of C we can write as R. Okay? What they are really testing is that you know that the sine of this one will be the cosine of that one, which makes sense. Both sine and cosine are over hypotenuse, correct? And what is opposite one angle is adjacent to the other. So what is opposite for C is adjacent for B. Okay? Which equation below represents lines that are perpendicular to the line that contains 1, -2, and 3, 4? Select all that apply. As far as I'm concerned, this is an algebra question. What I did was I found the slope. Okay? The slope of this line is 3. So if I want perpendicular, what slope is going to be perpendicular to 3?
-1/3.
-1/3. Yeah, Tyler.
I got for the slope, I got 5 over 3.
Then you did it wrong. How'd you do it?
It's 3 plus 2 and it's 4 minus 1. 'Cause
What?
one of them is a negative.
3 plus 2, though, but 3 is the x, not a y. Your y's are 4 and 2.
Dang it.
Okay.
I messed up.
Okay. So, this has a slope of 3, right? Not perpendicular. This has a slope of 3, right? Not perpendicular. For D and E, I had to rewrite them into slope-intercept form. So yes, I did 3y equals -x plus 9. And then I saw, oh yeah, when I divide this by 3, I'm going to get -1/3. Okay? On this one, y equals -3x. Well, that's not a negative reciprocal. This is really Algebra 1. To me. But hey, what do I know? Okay, number 9. This was the one problem I could not do last year. I had to call somebody to help me. I couldn't figure out what it was. And I will admit, when I looked at it again this year, I went, damn it, I don't remember how to do it. And then I remembered, oh yeah, I think I'm supposed to use midsegment theorem, and that's what you do. So, for number 9. Well, we can at least say P to B must be 6, right? And if B to C is 6, and they tell me that M is the center, then that's 3, and that's 3. Okay? I'm not sure that you would ever know what. Did anybody know what to do on this one? I'm just curious.
No,
I
I just
did, but I
guessed.
forgot.
I just knew it had to be bigger than 6, so I was guessing.
Okay, okay.
C or D.
So basically, and maybe this will trigger it on the EOC. If you draw a line here, P to B is a radius, right? So it's 6. P to F is a radius, right? So it's 6. M to E is 3. What you actually have now, whoa, it's really like a wide highlighter. You have triangle. And 3 is the midsegment, right?
This is like that one with that you kept doing on the backboard. It was on one of our test reviews.
See, that's, but now you start to see why
It was
I
like a
keep
light
doing
shine.
them, and they're under test reviews.
Is this mine?
Hello? Yes. No, never reach back to me. Nothing.
It's
Uh-huh.
Go up there.
Okay. Okay.
Nick out there.
Okay.
He's the Disney. Supposed to be the guy.
Okay.
He is.
Okay, great. Mhm. Okay, thank you very much. I'll try and splice some of this out, yeah. No, there's no ridge review this week. I figure you have enough to work on. Okay, so,
Was the one last week?
shh, no. So Anna, not over spring break. So Anna was saying,
It might have been a mountain. It might have been a light shining. I just remember doing it.
okay, what? It might, what, a what?
It might have been a light and it was like shining, or like a mountain. I don't really
Okay, but point being, I like that she's at least remembering that, like, oh, this triggered her memory of something we did before, because the benefit I've had this year is that I have taught this once already, so I know that by the time we got to EOC, what type of questions kept coming up. So what you're dealing with here now is a triangle. That means this part here, which is 9, has to be congruent to this part here. So this part here has to be 9. So this part here has to be, now that doesn't really help you yet though, does it? Whoa. Because you want ED. So, okay. This was, I know it moved there, this was my point M, E, and that was 3, right? And this whole length is 9. But since this is tangent here, when it intersects with a radius, it makes what degree angle?
Right.
90. So 3 squared, which is 9, right? Plus b squared, which we don't know, and the hypotenuse is 9. So 91 minus 9 is 72. So if b squared equals 72, b is the square root of 72. The key here is getting that you are using midsegment theorem. Hopefully, in 2 weeks, not even, in 7 days, 8 days, if you have a problem like this, you might trigger your memory and you might be like, oh yeah, I remember I use midsegment theorem.
Isn't it 90s?
So whatever it is. What is it?
I think it's 9.
You think it's 9. Okay. Number 10. Okay? 2.76 and 3.87 in hundreds, right? So that's 276 miles high and 387 miles wide. Gives me a total area of, is that the one, I have it written here, I have 10,432,800. Why do I have that written? Yeah.
It's 2.7.
Yes, but 2.76 in hundreds means 276 miles long. Right. Okay?
What'd you have?
What did you get?
106,812.
Okay, so it's 106,812. Okay? That's the area. Correct? We're doing population density. What goes on top in population density? Yes.
The 5,029,000.
So the 5,029,196 divided by 106,812. But that gives me, oh, that's right? What was the answer? 47. Okay? That gives me the correct answer of 47 people per mile. Okay? What did you do, Tyler? You did 2.76 times? Okay. So that's what you have to do. I will admit my weakest part is like the simple converting like hundreds to numbers, or like the question that talks about the 15,000 liters. So, she has it showing up on her paper. She's so thrilled. Okay. So, guys, for number 11, okay, they're going to be dilated from center P. What we want you to get here is that anything that goes through P when it dilates, since it's dilating on that, is still going to be there. If I take this line, okay, and this doesn't even really make sense if you think about it. This is a stupid example because a line has no length, right? It might have made sense if it had been a line segment. Because why can't I dilate a line?
Because it goes on.
It goes on forever. But I could dilate a line segment, correct? So if I dilated a line segment from P, and it would still rest on P. Think about when we dilated figures and we dilated them from 0, 0, and one of the vertices was at 0, 0. If we dilated a figure, the new figure got bigger, but one point stayed on 0, 0, because that was the center of dilation. Okay? So PQ, the new PQ, is going to be the same line. Okay? So it, at this point, is either B or D. Think about this. If this, I mean, you can even kind of imagine it. This is, okay? The answer is B, because when I dilate, when I make everything bigger, here, I can probably even do this. Ooh, watch this. You ready? Let's try and do this. Nah, that's not what I wanted to do. Booger? I know, and then you're going to hear me say booger on the video. Booger, say it with me. Okay. So guys, you can kind of see this. As I dilate this, okay? The line is just shifting further away from the point. That's really what happens. You won't see this on the video, but as I move this closer, see how like the figure slightly moves down? Whoa, I don't even know what I'm doing there. Okay?
How would it be?
Because it's parallel. This isn't going to show up in the video. But if it's here, okay, think about it. if I move this twice the distance away from P, instead of being here, it's being here. It's still parallel to where it started.
Wait, PQ just like
PQ
that makes sense.
doesn't move. I mean, first of all, as I said, it's a bad example because a line segment, it says it's a line. Does that help a little bit with 11?
Yeah.
These are going to be long videos for you guys to watch. Sorry. Oh!
Like 6 hours.
Well, if I do one in each class, you'll have 3 others to watch. You're fine with it? Oh, yay. Okay, shh. So, the unmanned aerial vehicle is basically what they put up to, like, look at stuff. Okay, it's like a drone. Right? An unmanned aerial vehicle is like a drone. Okay? And its figure represents, okay, so, shh, guys. This figure, this drawing is representing a moment in time. Okay? This is directly over the forest floor here. And it is flying 1,000 meters above. Point A represents the location of a small fire. If the field of the camera is 20 degrees, what that means is this angle here is 20 degrees. When it looks down, it sees out 20 degrees. Not very wide camera, right? Okay, it takes a picture directly over point D, what is the approximate width of the forest floor that can be captured in the picture. So it's flying and it's taking pictures, maybe for the rescue crews to be able to have an idea of what the terrain looks like. Okay, so yes.
Are you going to be doing the trigonometry?
Yeah, we're going to be doing the trick.
1,000 because each one is 10.
Right, very good. So this is, we're going to break this into a right angle. Each of these is 10, and this is 1,000, and I want to find this, correct? So that's opposite, and 1,000 is adjacent. So I'm dealing with tangent. So the tangent of a 10-degree angle is x, which in this case is my opposite, over 1,000. So in your calculator, 10 tangent times 1,000.
648.
What?
36.
What?
648.
Try that again. 10 tangent times 1,000. You should have 176.32. Okay? What? Are you stuck on radians? Did you press the second button? You should not be.
No, I just pressed 10, 10.
He's on rad. He's on rad.
You're on rad. Oh. So, guys, you should get 176.32, but as Tyler said, there's 2 of these, right? So times 2, 352.65, so that's 353 meters. Ooh, we have time for one more.
Yes.
Number 13. Okay. Guys, this gives you 2 pyramids. Okay? They've already figured out the area of the base of the pyramid, correct? So you take the area of the base, you times it by the height, and then what do? You divide by 3, and why divide by 3?
Pointy top.
Not because it's 3 sides, there's 4 sides to a pyramid. Has a pointy top. Okay, square base, 4 sides. So I got, when I did that the Great Pyramid of Giza had a volume of 2,593,100. Do you guys agree with me? Because I'm trying to read my writing from 2 weeks ago. 2,593,100, or is it 592,000?
I got that.
Okay, 92, okay. And then the Pyramid of whatever, that Cuckoo Clan, okay, which is in Mexico. So obviously, and they say this, the pyramids in Mexico, much smaller than the pyramids in Egypt. The approximate difference means what? Subtraction. Okay? So when you subtract, you get 2,562,000 cubic meters. Okay, hold on, let me stop.